All right, hello. Today I'm going to be talking about the HashiCorp formula to open source software. I got a great intro, but if you want to ask me a question today or anytime and you can't find me, then feel free to find me via Twitter. That'll get you my email or anything else. So I really love GitHub, and I really love GitHub because I love open source a lot more, and GitHub enabled me to do open source much more successfully than I ever could have imagined. And my love for open source really goes back to my childhood, and I very confidently can say that I wouldn't be where I am without open source. And I don't mean that in the way that I started a company based on open source or anything. I mean it a lot earlier in that I probably wouldn't even be the programmer, or maybe wouldn't have even programmed if I hadn't found open source. So I taught myself programming when I was 12, and the way I taught myself programming was I actually printed out the intro section to the PHP manual. It was like 30 pages on dead trees, and every day walking to middle school for about, I don't know, 3 months, I would just read it over the same 30 pages. I just kept reading because I didn't understand anything. But after about 3 months, I started understanding at a very basic level, what a variable is, what a conditional is, what a loop is. But even after 3 months, I was really struggling to tie these pieces together to make something, to actually do something with it. The most I could do was do little tricks like enter your name. If you enter this name, I say hello. If you enter another name, I say goodbye, like really basic things. And a huge turning point for me was really chance, Googling the right thing, finding software that had the source code available, and I didn't know at the time that it had a name or there was anything about it, but I downloaded it, and I can remember for at least 5 days, for at least a week, a Monday through Friday, after school every day I'd go home, and for like 3 hours I would just study this source code and take parts of it and put it in my own programs and see what happened, and it was a huge learning experience. In that 1 or 2 week period of reading the source code, I came so much farther than the 3 months of reading the PHP manual every day. And that really began my journey for open source. So as I was growing up, as I got a little bit older, kids any age have idols, have like what I would quote unquote call a rock star. And for a lot of kids, they're professional athletes, celebrities, musicians, pick something, maybe even their family. For me, it's really sad, but my idols were really open source people, and I put 3 of them up here. The list constantly changed and was bigger, but these are very identifiable people. And if you don't know, from left to right, it's Yehuda Katz, John Resig, and David Heinemeier Hansson, and they created these things or worked on these things. And I really looked up to these people. I watched every single talk I could get my hands on that any of them ever gave. I read every single blog post. I read their code. I looked at their commit style. I looked at sort of everything to try to understand how they worked. And I looked up them for different reasons. So the first person I actually found was John Resig in the middle. And what was really amazing about John Resig is everyone here has to know jQuery. And jQuery is one of the biggest, most used open source projects on the internet. And he created jQuery, I don't remember, but I think it was like when he was 13. And when I sort of discovered John Resig and his blog, I was 16. So I just remember being really struck by the fact that this person, and we're about the same age, I think, or he might be a little older, a little younger, but I just remember thinking that this person created something as successful as jQuery 3 years ahead of when I even found out about him, and I was doing nothing really at the time. And instead of being like, this really motivated me. It showed me that it was possible. It was something that I didn't even think was possible, and it showed me it was possible, and really inspired me to do more. Yehuda Katz is just prolific. He seems to work on all the right things at the right time, and David Heinemeier Hansson is unique. But what's really interesting about him to me is he's also a very successful entrepreneur. So all these people were sort of my version of what I looked up to and what I really wanted to be. So around 2006, I started doing open source software. So about 4 years into programming, by some definition, I started contributing to open source projects, finding projects I could work on, Actually, how I got into it was building mods for open source software, for forum software, actually, which is kind of weird. But in 2006 when I started doing it. And about 7 years later, this thing came out in 2013. You could look up the definition, how they measured it. But in 2013, I ended up being number 8 on the most active GitHub users list. And it's a vanity, superficial thing, but it's still, I was really proud and happy to see this because it showed the progress I had made in sort of the 7 years since I started trying to do open source, and in the about 11 years since I even found what open source software is. And shortly after that, I founded HashiCorp, and HashiCorp also really loves open source software. Most of our tools are based on open source software. And we made a bunch of things, and I'm not going to talk about any of them, but of all the things we made, more just vanity metrics, but of all the things we made, all of them that are open source have more than 1,500 GitHub stars. Over half of them have over 5,000 GitHub stars, and one of them has about 12,000 GitHub stars. And again, these are all vanity, superficial things that don't really mean anything, but they are a measure of some form of usage and interest and hitting a market that's interesting. And I'm really proud of what we've achieved. And what's really interesting, and someone told me I should give a talk about this, is that what someone told me was, look, if you do something one time, you could have gotten really lucky. If you do something twice, people could still claim it's luck or that it's just a coincidence that you did twice. 3 times is a pattern, and we've more or less, depending on you count, have done it 5, 6, 7, or 8 times. And at that point, the way I would define it is formulaic. I like to think that we go into every open source project using the same formula that changes over time as we learn new things, but we go into every new project following the same steps because we know it works before, and then we tweak things that didn't work as well, and maybe it works a little bit better. And sort of at this point, I'm pretty confident that we could launch new open source projects successfully, given enough time and energy. And a lot of people also say that it's easier when you already have one successful project, and that's definitely true. There's parts of this formula that aren't as big of an issue anymore, and I'll talk about those. But I've done it a few times, and I think that it's still very formulaic. You don't need a previous success to do it. And really the whole point of this talk is that you could do it too, that anybody could do it. So my first couple projects I built while I was a full-time student, had a full-time job, and I didn't have a great job. So the first time I did it, I was in college. I had a lot of time, which was the big benefit. The second project I made, I had a full-time job outside of college, so I didn't have as much time. It was a little bit more difficult. But I think that anybody here could do it. And this talk isn't going to give you everything you need to do it, but I think this is one of the talks that I wish the content sort of existed when I was starting something, to at least give me a framework to work around. And I hope that it could kind of guide you in that direction too, if you want to get involved in open source or try to start working on open source. So really quickly, before we dive into the formula, I want to go back to 2007. In 2007, I worked for Apple, and I was a freshman in college, so this isn't Apple Incorporated, this is Apple Retail. And I worked in a store a lot like this. I walked around the floor a lot like this. And my job at Apple, my title was Mac Specialist, which basically meant I was a Mac salesperson. Didn't earn commission, but I was a Mac salesperson. There was iPod specialist, there was iPhone specialist. I was a Mac specialist. And I would walk the floor. And to this day, I consider the 1 year I worked at Apple Retail to be some of the most formative teachings I've ever received, that really molded in a profound way how I build and design software and work with software communities. And I could probably talk for an hour about the various stories and things I've learned at the Apple Store, but I need to boil it down a lot quicker so we can move on. One of the lessons I learned is that look and feel matters. As an engineer, it's easy to put the technology or the implementation on a pedestal. And what Apple really taught me is that the implementation, the guts of it, need to work, but nobody cares. People want things to work, and they want things to look nice and feel nice when they work. They don't care how the gears are turning on the inside. Another part of look and feel matters is in this store. So I had to help sell computers, and when I wasn't helping a customer sell computers, we were expected to walk around and look welcoming to help anybody else. But as we were walking around, there's a word for it, and I can't remember it anymore, but we had to basically align all the display units. And so Apple has really strict rules for how you do this, to the point where if you look, for example, at all these iPads down here, they almost certainly have an exact grain of wood that the front of the iPad must be sitting on if no customer is actively using it. And as an employee, you're expected to learn all these rules. Another rule I remember, for example, is that the Magic Mouse on an iMac keyboard must be a hand's distance away from the keyboard, not more, not less. And these are funny rules, but you would get yelled at them. Everyone at the Apple Store has a radio, and it was really not abnormal to hear a manager or even another employee call on the phone and say, like, hey, the iPhones are out of alignment. You need to fix the iPhones your next time around. And so Apple Stores are really funny because they're chaotic, and they're a constant source of entropy and anti-entropy happening in real time. So go to an Apple Store, and at any given moment, something will be out of alignment. But if you look about 30 seconds later, it's very likely it's going to be fixed, and you wouldn't have seen it happen. You actually get really good at doing it without people even noticing. So, for example, I'd be helping to sell a computer. I'd be talking to someone and be like, oh, okay, let's go look at the laptops. And they would turn to go look at the printers. And they'd turn to go look at the printers, and I would follow them, but before I'd follow them, I'd quickly fix two and then go follow them. So you get really good at this. And what it taught me was that these little details, do they actually matter to the function of anything? Not really. But what they matter is the perception of things, and the perception of things is really important. So that fits into the look and feel matters part of things. The other thing is design for humans. I'm going to come back to this a bunch of times, so I'm just going to skip it now, but keep it in the back of your mind. And the last thing is be welcoming and kind. I give Apple a lot of credit in 2007 we had to spend 2 8-hour days in a hotel room, like conference room, doing training for how to communicate with people. And they taught you really important things like like gender equality and belief equality and all these things. They just taught you how to treat people that walked into the store, because you see all sorts of different people. And these are high school and college kids in here, and it's an awesome thing to teach these kids. And one thing they taught, though, is that most people are generally kind. They want to be nice. Most people want to be nice. And this is important on the internet because there's a lot of mean people on the internet. But the thing to remember is that most people want to be nice. And then the other thing Apple always said was, if someone's not nice, they usually have a reason. They feel emotional for a reason that's not nice. And you would also feel uncomfortable if you had that reason. There's very few people that just want to be mean. They exist, but there's very few. So they taught you this because people will come into the Apple Store having spent thousands of dollars on a computer, and it doesn't work, and they're pissed off. And you need to not be pissed off in return. And so they taught you how to approach meanness. And this is really important with open source and the internet, and as we hire more people at HashiCorp, as the HashiCorp community grows, we experience more people that you would describe as toxic, and it gets you down. And one thing that we always try to tell our employees or even committers is there's some mean people, but most people are actually nice. Just be nice to them in return, show them you actually care, and they'll turn around eventually, usually. And ultimately, if they don't, get someone else to help you out. Hand it off to someone else. And that's something we did at Apple as well. It was, if you feel like you're approaching the edge where you can't be nice to somebody, even if they're being mean to you, you needed to hand it off to another employee. You weren't allowed to talk to that person anymore. The customer's always right. So, okay, so these were some lessons I learned. And like I said, I could probably talk a lot about Apple. I've blogged a lot about Apple. But let's dive into the formula of open source. And like I said, this formula has changed over the past 6+ years. I haven't always broke it down this way, but I built this given the history of our last 8 projects. So here's the 6-step thing that I broke it down to, and we're going to go over each one. So step 1 is obviously to find a problem that you want to solve. So find something you want to build a solution for. And I'm an engineer, and as an engineer, the thing I would always want to do is work on whatever is fun. And you should definitely, and there's no problem working on whatever is fun, but it matters what your goals are. If your goals are just to learn something and have fun, then working on whatever is fun is totally fine, and there's zero problems with that. If you actually want to build a project that's used by a lot of people, that could grow, and whatever your ambitions are, then fun should be an aspect of it, but it shouldn't be the driving factor. And that's hard to say, but really what you want to look for when you're finding a problem is something that could fix one of these three things or more than one of these three things. You want to find something that takes a lot of time and you feel like shouldn't take a lot of time. You feel like you could, the time spent is unnecessary. Something that costs more money than it should. You think that you could make something cheaper, or something that's error prone. So something that you feel that software could actually drastically lower the error rate on. And ideally, you want to find something that's more than one of these things. You also want it to be fun, but you want it to be fun plus these things. So for Vagrant, for example, it was time and errors. That was my major motivating factor. I was spending a lot of time getting started to work on a project, and it was so manual that I would usually mess it up after spending that much time. And ultimately, that costs a lot of money, but for Vagrant, the money actually ended up not mattering. The big ones were time and errors. And so in addition to once you figure this out, you need to really deeply, deeply understand the problem. And for me, I always look for problems or pain points that I'm experiencing myself because I know I understand the pain. But one thing I recommend is when you find a problem, go live it. Go experience that problem on a day-to-day basis. Experience how much pain does that actually cause you. If you realize the problem is not that painful, it's annoying but not that painful, it may not be a good idea to try to solve it. It might not be worth trying to solve it. But if it's something that is super frustrating and you think is causing you to make a bunch of mistakes, causing you to work longer than you want to, just isn't fun and you think you could solve it in a more fun way, then it's probably worth solving. But it's really hard to solve a problem that doesn't affect you. So even if you find a problem that doesn't affect you, go try to insert yourself in a position where it now is affecting you, because it'll motivate you a lot more to fix that problem. The next thing I do is ask these three questions. These are fairly uncomfortable questions because you really want specific answers out of these, but you rarely get those answers. So once you find a problem, at least what I want to do right away is just go solve it, go do it. But it's really important to ask these questions to learn about the environment first. So who else has tried to fix this? If there's almost certainly going to be someone that's tried to fix it if it's a real problem. If no one has tried to fix it, it's equally concerning in another direction, in that maybe it's not a real problem. But go figure out who's tried to fix this. Look at what they did to an extent you can legally, and ask yourself, why is my idea better, or how can I do better? And write all this stuff down. And then the last thing you want to ask are, what are the risks? There's risks in everything, and to a point, you should tolerate them, and at a certain point, they should deter you, but you want to know what they are. So ask sort of what are the risks. So for example, for HashiCorp, when we were building Vault, which is our security tool, this almost stopped us from doing Vault completely, was the risks. So the risk we saw with Vault was security is an area where if you don't do it properly, your reputation for everything could just be torn away. So our fear, the risk with Vault was, is it worth building this one open source project at the risk that we introduce a horrible vulnerability and our reputation for Vagrant, Packer, Console, Terraform, and any future thing we do is just gone. Actually, Armand's my co-founder, Armand and I talked about should we or should we not build Vault on these merits for probably 3 months before we ever moved to step 2 of this process. We did other things in the meantime, but we always came back to, do we really want to risk it? Eventually we did, obviously, and it's been okay, but those are the things you want to think about. And then the next thing is this 10x thing. And 10x gets a lot of bad rap for 10x engineers. I'm not going to talk about that. You could you have your own opinion on that. But 10x is something you want to aim for. An order of magnitude is something you want to aim for to be better than whatever else is out there. And the reason is because when you build something new, you're going to be replacing something old, and there is a cost to replacing something. And it may be financial, maybe time. It's almost certainly a mental cost to learn something. And so being even 2 times better, being twice as good, I found is just not good enough. If something is twice as good, the problem, and this is the worst thing, is that the old solution isn't better than you, but the old solution is good enough. And those are the worst 2 words as a engineer, because you know you could do better, but people are not moving to this better thing because the old thing is good enough. And so 10x is a little extreme, so at least I would say at least 3 times better. You want to be significantly better in some way than the previous thing, so they'll move to the new thing. And the project overall doesn't have to be better. So an example I'll give here is with Terraform. And I should mention, as part of the process, we actually have a section where we do this on paper. We actually have a section where we write why our idea is 10 times better, or what part of our idea is 10 times better, we believe. So for Terraform, I'll give you an example. Terraform is something that builds infrastructure. And believe it or not, nothing else on the market when we built it had the ability to tell you what it was going to do. Everything that built infrastructure was either you didn't build it, or it's building it right now, and you're out of control. It's just going. And there was no step in between. So the way we thought we would make Terraform 10 times better was building a step that told you what it was going to do before it did it, and lets you hit a button to confirm before it did it. And the proof of that, we believed it was 10 times better. And the proof of that was very early on, when Terraform was still quite buggy. We were able to get a meeting with Yelp, and Yelp was continues to be one of our biggest users of Terraform. And I walked into a meeting with Yelp, big, nice wooden conference room table with probably 30 people in the room that were all various ops, security, dev, leadership type people. And I gave them a 5-minute demo of Terraform. And I got past the plan section, and someone raised their hand and said, and started asking a bunch of questions about what I just did. And after that, the 2 the ops and dev managers talked for a little bit, and then said, "Done. We're getting rid of CloudFormation. We're using Terraform starting right now because of that. So let's ask questions about let's stop the demo and start asking deeper questions about Terraform." And that's what you want. You really want something that's so much better that you show somebody something, and because of that one thing, it invalidates everything they've previously done, and they need to move to the new thing. And so 2x better is not good enough, and so on. So you really want to aim for something like this. Okay, so we have a problem. We know the idea. We know how we're gonna. We know why we believe our idea is better. And so step 2 is starting to design a solution. And a lot of people at this point will reach and start trying to write code. And very painfully, you can't write code yet, or I don't believe you should write code yet. You instead want to write a lot of human language. So for Terraform, for example, we do this on Google Docs. This is Terraform's actual initial design. This never became Terraform. None of this that is written here ever became Terraform. And that'll become important. But this is Terraform's initial design, and you can see by the scroll bar that it's a fairly lengthy document, not a tome by any means, but fairly lengthy. And we cover a bunch of things. And basically, what you want to cover in this is the why of what you're building, the what, and this is the important part. You want to design, in words, both the back end and the front end at the same time. And so in this one, you could see in the outline that we have a section on both front end and back end. This is the section covering the front end, and this is the section covering the back end. And the way we define that is the back end is any internals of the thing. It's how the thing works internally. It's the technical details. It's the computer sciencey stuff that's inside there. And what you want to aim for the internals is build something that designs for the future and gives you a technical edge. A huge benefit and a huge detriment of starting any new project is that you have a clean slate. So the huge benefit is that you have the ability to learn from other people's mistakes and do it a lot better. And the detriment is that they have code and a user base that's a head start to catch up with you. So it's sort of a race and a challenge, an engineering challenge, of whether you could build something better before they can. And so with the backend design, you really want to think, I don't have backwards compatibility issues right now. I don't have any assumptions right now. What could I do that's very different that gives me a great foundation for the future? And so with Terraform, for example, one of those foundational things we decided was Terraform would be based very, very heavily on graph theory. There's a full talk I tweeted about this week that the Terraform project lead gave for an hour about how graph theory has made Terraform possible. So if you want to find that, it's on Twitter from this week. But this is what you want to do. And the last thing you want to do is understand trade-offs, because every choice has trade-offs, and you can't do everything. So a good example here is when we were designing Surf and Consul. They were our first distributed systems, and we chose a bunch of protocols and things to base it on. And there was a lot of cases where I would say something like, "Oh, it'd be cool if we did this." And then we'd think about it and say, okay, well, given our choices, that's actually technically just impossible. We'll never, ever be able to do that. So is it important that we're ever able to do that? Or are we OK with that never being possible and getting these other benefits? So understand the trade-offs, because there is some. At a very basic level, for example, are you building a distributed system, or are you building a single server system? The benefit of the distributed system is that it could be highly available if you do it correctly. The benefit of the single server system is it's a lot easier to implement, and you could do things, you could reason about things that you technically, as far as we know theoretically right now, cannot reason about in a distributed system. So you have to trade off these things and understand those trade-offs very early on, because these aren't things that you could fix later. This is why I sort of laugh when any project says, oh, it's single server today, it'll be a distributed system tomorrow. It's like, well, you're going to build features into a single server that when you try to convert it to a distributed system, you're going to have to remove, or they're not going to theoretically work anymore. And so it's really important to understand these trade-offs early on. And then the front-end design, I consider the front end anything user-facing. So this could be a web application if you're building a web application. It could be an app, like on your phone or something, if you're building an app. For us, it's almost always the terminal is what we consider the front end. And we design that at the same time as the back end. And we design it kind of separate. And the way we design the front end is really thinking, how do I want to use this in an ideal world? I don't think about sort of what's technically possible. I don't think about how we're designing the back end. I think about if I were having this problem, what would I want the terminal to look like for me to solve it? And I use that experience to help guide the back end and vice versa. So build the front end. Design for humans comes up again, which is that people need to use your software, and people like fun things. So try to make your front end have nice errors. Try to make it fun to use, intuitive. Like, what are the steps you're going to take? How long does it take to go through? How is the program communicating to the person? There's a human interaction between software. So design for people. And then playtest the front end. So we actually string up a bunch of bash scripts that emulates the front end, and nothing actually works, right? We fake the reading the config in something, but for example, with Terraform, we wanted to spin up a bunch of servers. We didn't implement any of Terraform yet, but we strung up a bunch of bash scripts to make it look like Terraform was done, and we went through the steps of what we wanted to achieve. We wrote the configuration that there was no parser for, nothing understood it. We did everything. We actually used Terraform before almost any Terraform code existed, and we found a bunch of things that weren't fun, and so playtest the front end because you can. You don't need something to work in order to see if it's good. You could, basically with the front end, you just assume the back end's going to work. You assume that you could engineer something, but you want the front end to feel right. So at this point, we're still not writing code. So the next step is to build the 0.1. And finally, engineers could rejoice because this is the part where we actually get to write code. And depending on how you do it, the first two steps might take a long time. But at this point, you kind of have smooth sailing for a while, just writing code. And for a 0.1, I usually aim at a 3 to 6 month time frame, whether you're full-time or part-time. If you're doing full-time, you could just do more in that period of time. But if you're part-time doing this at home in your free time, you just cut features and do less. But 3 to 6 months has always felt right to me. Shorter feels like it's a little bit, you're building something that's a little bit too weak. There's not enough in there in 3 months. You could do a lot better in 3 months. And longer than 6 months, to me, is just mentally tiring. If I'm building something that for 6 months doesn't actually get any users, even if the user is just me, it's not actually usable, I get kind of burnt out. Like the project becomes far less interesting after 6 months. So I really aim for 3 to 6 months in order to get something out there and get some positive reinforcement, hopefully, that I'm on the right track. And so with a 0.1, you really want to aim for the primary use case, basically a demo, a basic use case working really great, with the understanding that the edge cases probably won't work well and there's going to be bugs. The best thing you could do is just guard those bugs with errors. So for example, with Terraform 0.1, actually Terraform 0.1 to 0.2, we internally joke at HashiCorp that it was a command line to exercise looking at Go panic stack traces. Because if you did anything outside of really the happy path, it would probably panic, which is not human friendly. But that's sort of the way a 0.1 goes. It shows people where you're headed. It shows people what you're doing and what's possible, with the understanding that it's super early and you're going to get there. I like to think of a 0.1 as a path to a 1.0. A 0.1 is not something that should stand on its own. It's not something that should necessarily be that good, but it should show people a data point on a line that you're heading towards a 1.0. And even at Terraform 0.1, I would use it, and it would crash, and it wouldn't work, and I'd be like, dang it. But I'd be like, but this is how I want things to work. This is definitely the direction that I want things to go. And so, yeah. And when you're building a 0.1, follow the design doc you made. So this is what makes building the 0.1 so easy, and part of the reason that I believe at HashiCorp we've been able to build software so quickly is because by the time we're coding, the decisions of what we're coding have already been made for us in the Google Doc. For example, with Terraform, we knew we were based on graph theory, so one of the first things we did was build a Go library, because one didn't exist, for abstract graph theory concepts, like just representing graphs, acyclic graphs, walking them, finding the root, doing transformations on graphs. Very abstract, but we were able to work on something really abstract, knowing that it served a purpose, knowing pretty conclusively that it served a purpose towards the 1.0. And even with things like Vault, Vault actually, Armand and I started on opposite ends. I started in the front end, and Armand started on the back end. And we never once saw Vault run, other than automated tests. We never actually ran Vault manually until about a week before we shipped the 0.1. We just never saw it work, but we didn't have to because we automated tested everything. We knew the APIs we're heading towards. We knew how the CLI was going to look. We ran it on a playtest environment. We knew as how we wanted it to work. And by the week before, when we finally connected the core, the HTTP API, the CLI, and all those things together, the unit tests made sure they all worked, and then the play tests and stuff made sure that we ran it, and we're like, yep, this is exactly sort of what we designed and what we wanted it to be. And it's very, very normal to go back. So like I showed you, this was the Terraform's initial design. About a week into building the 0.1, we realized that it would never work. So we did a complete do-over, which we called Terraform Simplified. And you can even see in the sidebar that there's a section called Abandoned Ideas from Complicated Terraform. And so we talked about what went wrong, why we didn't do it. And you can notice this is a lot shorter, too. We simplified things actually quite a bit. And this became Terraform. So if you were to read this document, if this document were public, it could be. There's nothing secret in there. But it would be very familiar to any Terraform user. This became Terraform, whereas the other one would sound really cool and fancy, but it never became anything. And then the last thing is the code as craft. So when you're coding a 0.1, again, 0.1 is just a path on the way to a 1.0. It's not something you try to get out as fast as possible. It's not something that ends there. So you really want to make sure you're automated testing from the beginning. You care about how code is laid out, care about the way it's designed, because the code you write into a 0.1 very rarely gets changed. There's code that's in Vagrant that hasn't changed in 7 years. There's most of our projects, the core of them, really rarely change. They've gone 3 or 4 years without the core code changing in any significant way other than to fix bugs. So what you're building for the 0.1 is going to last for a really long time, and people are going to run it for a really long time. So treat it as a craft and care about it. OK, almost done here. So the next section is documentation and landing page. So most open source projects just say, I'll make a pretty README, and that's good enough. So yes, do that. but also make real docs and maybe a website. And this comes back to designing for humans. So what you just spent 3 to 6 months doing is writing a lot of code, and code talks to computers. Code talks to machines. So you did a great job spending 6 months talking to a machine. It's now time to spend some little bit of time writing docs in human language, which is the only way you'll ever talk to a human. Humans will not talk to the code. So if you want humans to actually use your software, you really, really need docs. And docs really are painful to write, but you need to write them. And the other thing is documentation is not a landing page. So if you visit your website on GitHub pages or anything and it's immediately docs, it's better than not having docs, but it's not equal to a landing page. So documentation tells you how something works, gives you reference material, answers questions about how to use something. A landing page tells you what something is and why you want to use it. It's a lot more marketing, but you need marketing in order for people to understand what you're doing. And look and feel matters. So I don't have long enough to tell you the story of why look and feel matters. But here are our websites. I'm going to go through all of them, and you'll see they're very similar. So this is the Vagrant website. And the answers we try to solve on the landing pages, these are the landing pages, is what is this, how do I get started, and from an open source perspective, how could I get involved? So there's Vagrant. You could see download, get started, and then community stuff is up right in the top bar. And then here's console. I'm going to just blast through them, but you'll recognize common elements throughout all of them. What it is really big. What it is really big. Download's obvious. A little bit different, but still all those elements are there. And you'll see a change in style throughout, because Vagrant, you got to remember, is 6 years old. The design is 4 years old. Vault's design is about 11 months old. So stylistically, things change. But at a fundamental level, answering the questions of what is it, how can I get started, how can I get involved, still exist. Then we go to the docs. So this is the Vagrant documentation. So for documentation, we use what's called human ordering. We don't order alphabetically. We order in a way that we expect people to discover things. Like if you get started with Vagrant or any of our projects, we try to order the doc sidebar in a way that intuitively is a path or journey that you would travel through to get things. Because beginners want that journey, and advanced people are just going to know where things are. They're going to be there enough to know where things are. You want to cover both high and low level stuff. So there's sections on, for example, getting started, very high level, and then there's lower level sections on like networking. You want to cover both in the documentation. And then repeat yourself. So this took me a really long time to figure out. As an engineer, we're taught to not repeat ourselves, to abstract, to write reusable code so that we don't need to write the same code over and over. I treated docs the same way. I would write a document once and link to it everywhere and use a link as sort of an abstraction unit. That's really unfriendly to people. People clicking a link moves them into a totally different context, and people don't like doing it, is what I found. So instead, I repeat myself a lot more. I explain the same concept, different wording, all over the place. And it's harder to maintain, but it makes a much nicer, welcoming experience. So we'll go through these. Again, they all look pretty similar. It'll take you about a week or 40 hours, like a full week, to write documentation. It's a really, really sad week, but it pays off, and the documentation lasts forever. So last section, I'm almost out of time. So shipping, you could celebrate. This is an awesome day. There's a lot of endorphins. You're really happy. Hopefully people are saying nice things. There will be people saying mean things, but ignore them. And it's great. But you want to start working about a 0.2 right away. 0.1s are rough, as I covered. 0.2 should be fast to clean up things and just ship features that you wanted to get into the 0.1 but didn't have time. For HashiCorp, we actually aim for 0.3 to 0.5 to be where we feel comfortable for someone running it in production. For other companies, it could be later, it could be earlier. Some companies go straight to 1.0. It matters how you go. One of the last things I want to cover is public speaking. When I first built Vagrant, I went through the mantra of, like, if you build it, they will come. I completely do not believe in that at all anymore. And if you look at Vagrant's trajectory, about 9 months in, it was still getting only 200 downloads a month. Actually, that doesn't show that for 6 months it wasn't growing or shrinking in downloads at all. It was just a line. But you could see very quickly after, it started growing pretty crazy. And the difference is that about 9 months in, I gave my first talk at a local meetup. About 12 months in, I started talking at conferences, and it sort of went from there. So there's meetups, there's local conferences, and I would go in this order, and you don't need to reach every single one, right? And the thing about it is that meetups are free. Remote conferences cost money, but if you're creative, there's ways to work around this. A lot of conferences will help cover some of the costs. Your employer will often help cover some of the costs if you rep them in some way. So just sort of get creative and find an opportunity to talk about it. And then the last thing is community. So I wish I could spend a lot more time, even though I'm over time right now, to talk about community. I could give a talk on it. The 3 bullet points I'll tell you is just be kind, be helpful, and be welcoming all the time. And if you feel like you can't be one of these 3 things, remove yourself from the situation, put someone else there, or if there is no one else to go there, it's the internet. You could just step away from the computer. So just step away, go do something happy, and just chill out because it'll be okay. And negative people will come. There will be bad people that come and just rain on your parade. But try to be nice to them, and if they don't be nice in return, just turn them away. Just turn it off. And all of this I learned from Apple. I blogged about how to interact with people on my blog, and so Google that if you want. And that's it. I think you could all do it. It's very possible. It's fun, and good luck. Thank you.